to the today video lecture series on simulation software used in heat transfer. So, thermal simulation is a visual process used to analyze and predict how heat is distributed within a design object or system using mathematical models and algorithms to simulate thermal behavior aids in assessing the impact of temperature on various components. By inputting material properties, environmental conditions, and heat sources simulations can provide insights to temperature gradients, hotspots, and overall thermal performance. Designs optimized for heat dissipation, preventing overheating, ensure the reliability and safety of any product susceptible to temperature-related issues. Thermal simulation is a conduction refers to heat transfer between substances in direct contact with each other. In theory, heat energy passes from the hot to the cold end of substance and is directly related to the conductivity of the material. And convection simulation is also known as convective heat transfer, refers to the transfer of heat between two areas through the movement fluids, common in liquids and gases. It occurs when fluid molecules absorb heat and change density, leading to convection currents. And radiation simulation, radiation or radiative heat transfer is the transfer of heat via electromagnetic waves. In product design, radiation usually starts to play a role in high temperature difference scenarios and weakly cooled application like natural convection cooled product. Thermomechanical analysis for many industrial applications, simulating the stress response to thermal loads and understanding failure is essential. Applications include polymeric materials, valves, pipes, basket strains, BCP, pressure vessels, and more. And these are the some simulation softwares used for heat transfer analysis is Ancient Fluent software and SolidWorks flow simulation and COMSOL multiphysics and OpenFOAM and Autodesk CFD and ANSYS XPact. And the case study of thermal analysis of heat transfer with the ANSYS Discovery. So this is the desktop central processing unit must run at the temperature between the 70 to 80 degrees Celsius to safely perform avoid thermal degradation. And however, during their usage, CPU can generate from a few watts to nearly 1000 watt of heat, leading to dangerously high temperatures. Heat sink in the figure are components that sit on the top of the heat generating computer pods, draw the heat away. The heat is conducted from the CPU into the heat sink and then transferred to a surrounding fluid via convection. And once the model has been set up, the simulation can be run in ANSYS Discovery. For this case, the explore stage was used with the enables fast simulation results through CPU and solver. And however, the same analysis can be performed in the refined solver, which make use of flagship CPU-based solver, also found in ANSYS and also the other mechanical parts. In this study, the simplification of a common alternative to aluminum with better thermal conductivity, which is often used in these applications. Copper will be tested as figure number 5 and the design points, and it should be mentioned that copper is more expensive than aluminum and used to benefit of the lower temperature may not be justified by increasing of the cast. And altering the geometry, we can possible solution to bring the temperature so down to the temperature reduction. And these images are explained about the simulation can be result of the power flow in the figure. And the result of analysis show that the flow speed of at least 9 meters per second is needed to bring the temperature of CPU below the critical threshold of 80 degrees Celsius. And in this graph, we explain about the defined variation of the maximum temperature to the flow inlet parameter. So here is the critical temperature will located as the temperature ranges between 80 to 100 degree Celsius. And conclusion, we can decide the investigated how the positioning of the fan affect the cooling of the heat sink of potentially if other type of fluids could provide better cooling. So this is some softwares used in heat transfer in aerospace engineering, and what is the software will relevant to with the applicant of the case study will also explain about the transfer mechanism. Thank you.